Titrations. Titrations are used to find out concentration of acid/alkali solutions. Making a standard solution. Any solution you know the exact concentration of is a definition of standard solution. Work out the moles, work out the mass. Place a weighing bolt on a digital balance and weigh out the mass of a solid. Tip into a beaker. Now re-weigh the bolt and subtract the mass of the bolt from the mass of the bolt and solid together to get the precise mass of the solid. Add distilled water to the beaker and stir until all the sodium hydroxide dissolves. In this case, that's what we're using. But whatever chemical you're given in the question. Tip the solution into a volumetric flask. Use a funnel to. Why do we use a funnel? To ensure it all goes in. All the solution goes into the volumetric flask. Rinse the beaker and stirring rod with distilled water. Add to the flask. As this, make sure no solute is clinging to the beaker/rod. Top the flask up to the correct volume with more distilled water. Make sure the bottom of meniscus reaches the line and add drop by drop when you get close to the line. Stop at the flask and turn upside down to ensure it's mixed. So in the exam, they can do one markers like, why do we turn it upside down? Stop at the flask and turn it upside down to ensure it's mixed. And it's usually just these one markers that it just depends how well you know the practical. Titrations allow you to find out how much acid is needed to neutralize a quantity of alkali, or the other way around, how much alkali is needed to neutralize a quantity of acid. We use a pipette to measure out a set volume of the solution you want the concentration of, put it into a flask and add a few drops of appropriate indicator to the flask. Fill the burette with standard solution of acid. Use a funnel to carefully pour acid into burette below eye level to avoid the acid splashing into your face/eyes, and now titrate. Do a rough titration to get an indicator of the end point, the exact point where the alkali is neutralized and indicator changes color. Add acid to alkali using the burette, giving the flask a regular swirl. Do an accurate titration. Take initial reading to see how much acid is in the burette. Run the acid into 2 centimeters cubed with end point. Add dropwise, as if you don't notice exactly when the color changes overshoot. Yeah, that's why we add dropwise, because if you don't, then you won't notice exactly when the color changes overshoot, therefore inaccurate results. Work the amount of acid used to neutralize alkali, aka final reading minus initial reading, and this volume is known as a titer. Repeat the titration until 3 concordant results. The two main, and that's really it. And obviously, if you get anomalous results, anomalies, you ignore them. 2 main indicators for acid/alkali reactions: methyl orange, red in acid, yellow in alkali; phenolphthalein, colorless in acid, pink in alkali. For acid/alkali reactions, obviously methyl orange, red in acid, yellow in alkali; phenolphthalein, colorless in acid, pink in alkali. We want indicators that change color quickly over a small pH range used, so we know exactly when the reaction ended. Therefore, universal indicator is no good, as a color change is too gradual color change.